Hello everyone. I'm Kailash Prasad, a PhD scholar from IIT Gandhinagar. This is the live session 9, and the main goal of this session is to discuss some of the concepts which has been discussed in class. And what we will do is we will try to solve some of the problems with the concept that has been discussed in the class. What have we done as of now in the sessions? We have discussed about number system, then Boolean algebra, then we also discussed about combinational function minimization, right? After that, we have discussed about the combination circuits like code converter, multiplexer, decoder, PLA. Then we have discussed about sequential circuits, which are latches, counter, shift register, FSM. Then we have discussed about the data converters like analog to digital converter, then digital to analog converter. And in the last week, what we have discussed was semiconductor memories. We have discussed some of the questions on SRAM, then DRAM, and also we have discussed on the ROM. Right. In today's session, our main goal is on what we call as microprocessors, and but before that, we'll be discussing about uh, what we call as hardware description languages. Okay. As of now, what we have done, and please ask question if you don't understand at any time while we are solving the questions. Uh, in today's session, we'll be discussing about what we call as hardware description language. So we have questions on hardware description language, hardware uh, description language, right? And there are a couple of hardware description language which are available. First one is Verilog. The second one is VHDL, right, which we'll be discussing in the which we have discussed in the NPTEL lecture, and we'll be solving questions on the basis of that. And the third one is what we call a system Verilog, right? So anybody wants to get into the RTL design or in the VLSI industry, this is the gateway for you to go into that, right? Because what you can do, you can learn this language, you can design, and you can apply for any of the companies. Now, let's start. The very first question which I have, you understand the HDL means hardware description language, right? As of now, what we have done, we have designed hardwares. Now, using block diagrams and gates, right? But what we want to do is we want to design hardwares using what we call as hardware description languages, and you can write down some programs, and what you can do, you can generate hardware. So that is the beauty of it, right? Suppose you want to design say a calculator, right? It is very easy to design using hardware description language. You can write the code of the calculator and it will convert the hardware for you. Similarly, if you want to design, say, processor, right? Processor is a very big design. You cannot design manually. The hardware description language will help you in designing the same. So the very first question which I have for today is which of the following statement is true for the hardware description language? And let us read out, and you have to answer the question. The first one is HDLs and computer programming languages are similar, right? So when I'm talking about computer programming languages, I'm talking about like computer programming, right? Whenever I'm talking about Python, okay, C, Java. So that's the first statement. Are HDLs and computer programming languages are similar? That's the first point. The second is HDLs describe hardware rather than executing a program on a computer. So what it is saying that the main job of the HDL is, yeah, two students have answered the question, and people are saying that it will be B. Let me explain whether which one of the answer is. Rather than executing a program on the computer, right? HDLs are used for designing hardware or not. That's the point. Third point is HDL describes software, not hardware. So this will be wrong, right? Because HDL says hardware description language, and computer programming language describe hardware. This is also wrong. So HDLs and computer programming languages are not similar. Why? Because computer programming languages run on computer, but HDLs are used to make the computers, right? So that's the difference. The only answer that is correct is B. That is hardware description languages describe hardware rather than executing program on a computer. Okay, so using hardware description language, what you can do, you can design the hardware. Any questions on this? Anyone? Have you understood? There was nothing to understand here, but if you have any question, you can ask. Okay, shall I go ahead? You can type yes if you have understood. Okay, thank you. So one confirmation is fine. Moving to the second, which of the following is the basic building block of a design? Knows the answer? If you have watched the videos, anybody knows the answer? A. Okay, Ranjit is saying A. What about other students? Any other student want to answer? Okay, B. I have two students who are saying B. Entity. So I have two options now: architecture or entity. Anybody else? Okay, Khalil is also saying B. So see, the basic building block is actually entity. Okay, in a very VHDL. Okay, and how do you define an entity? So what you do is you write entity. Okay, then you name the entity. So suppose I am writing as my underscore entity. Okay, and then you write is. Okay, and after that what you do, you write port, and in the port what you will do, you will define all the inputs and output ports. Okay, so how do you define that? Suppose I have two input ports and two output ports. I want to design an AND gate. Okay, so instead of my entity, what I will do, I will write an AND here. Okay, I will write an AND over here. Okay, and I have two inputs and one output. Okay, out. So how I will define, like, so I will write a is my input one, right? And I will define it as input. Okay, and then I will write standard logic. Okay, standard logic, like this. And after that, sorry, yeah, semicolon to it. Then I will write b, then again standard logic. Okay, and then what I will do, I will write out, and sorry, not out, yeah, it is out, right? I will change the name. I will write suppose y. Okay, so instead of out, I will write y, and then it has to be defined as output out, and then standard logic. Okay, so the basic building block of your uh, uh, design is what we call as entity. Okay.
Sir, can you explain more about entity?
Mm. Can I explain more about entity? What do you want to
I
explain?
don't know about entity, so can you explain it?
Okay, so do you know about by VHDL, anything about VHDL?
No, sir.
Okay, so do you want me to go through the VHDL first? So
I want to know about a entity, and if it covered that, then you please explain it.
see, okay, what I can tell you is entity. So how you write a code or the VHDL code using two or multiple aspects. So whenever you want to define any of the blocks or any of the hardware in the VHDL, right? Uh, the program, whatever you are writing, you can consider it as a black box. Okay, consider the program as a black box, and you will write something over there. I will be discussing, and this has been discussed in the class also. And if required, I will create a detailed lecture on VHDL, how to write a couple of codes on that. But for now, what you do, is this is a program or this is the hardware which you have to design. In our case, it is AND gate. Okay, and what I want to do is I want to the basic thing what I will do is I will write the ports. Okay, what my ports are. So I have two inputs A and B, and I have one output, right? And internally my program can be anything. Okay, so I will call this program or this block as my entity, and the input and output ports, whatever I want to define, is will be defined under entity. Okay, so entity is nothing but it is providing you what are the input and output ports you have, right? Which are the input and output ports you have. Okay, so suppose if I have two input and output ports, I will write like this entity, whatever the name of the entity is. My name is and entity. Okay, and you write is then port.
Your box is represented gate.
Box will be something, some process which we will define later on, but entity defines the input and output of your whatever the box you have, who you want to design, whatever gate you want to design, whatever logic you want to design. So entity represent that.
Okay, sir.
Okay.
Okay, sir.
Okay. Yeah. So okay, then we will move to the next question. I think I have a suggestion for you guys because this is a supplementary to your whatever discuss in the class, and if you can go through the lectures also, it will be extremely good. However, if you want, I will discuss in the next class how to write a code also, right? And in between question, if required, I will help you with some of the syntaxes. Okay. So moving to next question. Anybody knows Intel 8086? Okay, how much bit of processor it is? It's a simple question. Okay, Madhubalan is saying 16 bit. Any other? Anybody else? Intel 8086 is one of the first processors, microprocessors we had, right? And the answer is actually 16 bit, so nothing here. Okay, and you should know because whatever the current machine, whatever architecture it follows, it has been built upon Intel 8086 architecture, right? That is the reason why in your laptop, if you open, right, there will be some folder where it will be written cross 86. Okay, so it means cross 86 architecture is whatever the current architecture, the base architecture was 8086. Okay, that is the reason why this question is very important. That is the reason why 8086 is very important. Okay, so all the Intel architecture follows cross 86 architecture. Obviously it is not the basic one, it has been much more advanced, much more advanced. But if you will narrow down, if you want to try to understand the complex architecture, 8086 is the way to go. Okay, moving to next question. Verilog, see, Verilog or VHDL, right? These are two hardware description languages. Now, the question is, this hardware description language is has to be developed using some of the language. Okay. Now the question is, which of the language has been used to develop Verilog? Anybody knows? Okay, Madhubalan is saying C. C means Python. Are you saying? Okay, Manjunath is saying D. Khalil is saying A. Okay, Madhubalan is also saying A, means he is saying C programming. So the answer is yes, it is C programming, right? Today also many or most of the languages which are built on are on C or C++. Okay, if you see Python is a programming language, but many of the packages which are used in the Python, inside it actually is being made using C or C++. The question is why? Because the C is the one of the fastest language which we have, right? If you write a code in C, it will execute and compile very fast. Okay, so Verilog is also designed using C, and you can see when you will write the codes in Verilog, you will understand that it is following the patterns, or how we are writing in Verilog is it is following the nomenclatures of C itself. Okay, so that is the question number 4. Moving to question number 5 is which of the following is not defined in the entity. I have discussed, right? Uh, about entity. The question is which of the following is not defined in the entity. Madhubalan is saying D. Manjunath is also saying D. See, if I go over here, so this was the entity. So we have that, okay, what are my input and output ports? So all the ports names are defined. We have also defined what is the direction, right? Is it input or output, right? So we define the port names, we define the direction, and what else, right? Uh, we define all the ports, right? So we define the direction, we define the name of the signal, we define the ports, right? But we do not tell what is the behavior of the signal. The, what do you mean by behavior? Is whether whatever signal you are defining, it is going to do what, right? That we don't define over here, right? That you define inside the other block, which you have the architecture, you define everything inside it. Okay, but in the entity we only define the direction, the name, and the different ports, whatever you have. So the whoever said the answer D, that is correct. Okay, moving to question number 7. Okay. Anybody know about logic synthesis? What is logic synthesis, and what is the meaning of the logic synthesis? I have four options. Converting behavior level description to structure level netlist. Converting structure level netlist to behavior level description. Converting high level language to machine level language. Converting behavior level description to architecture level description. So many terms. Anybody wants to answer this? Okay, Khalil thinks D. Madhupalan thinks B. Okay, anybody else? So let me first tell you a couple of levels, okay, and then you will understand what is the process of synthesis is doing, because all of these are new things to you. Uh, so the top level you have is what we call as high level language, okay, high level language. Okay, so high level language will be C, Python, everything like that, right? After that, what you have is what you call the behavior level description, behavioral level, and these are written in VHDL, Verilog. Okay, then what you do, you have structure level netlist, structure level netlist. Okay, it's structure level netlist. So whatever you write, okay, you write it, okay, if this happens then you do this, if this happens then you do this. But that's not how our hardware looks like, right? Our hardware looks like in the form of AND gate, OR gate, NOR gate. So structure level netlist is in the form of that. And then what you have, the machine level language, right? Which is 1010, machine level 0101. You don't understand that, machine will understand. And between high level and behavior level, there is one more level that is called architecture level. Okay, but the question is, what is the process of synthesis mean, right? See, synthesis is related to hardware description language, right? And the two levels, which are architecture and high level, is beyond the scope of hardware description language, right? So we talk about behavioral level. Okay, and synthesis means you convert this behavior level into AND gate or gate. You just break it down. Okay, so the process of synthesis is converting the behavioral level description to structure level netlist. Okay, So this is how this is the process of synthesis is called. Everybody understand? Anybody has question?
So do we have name for other points? That means in case the first point is called as a logic synthesis, what is the second point is called as in case if you're converting the structure?
Okay. You cannot convert structure level to behavior, right? Because it is top down approach. Okay, so you have the behavioral, then you convert the structure. Again, you cannot directly convert high level to machine level, or if you want to do that, this is what we call as compiling. I think so, right? So compiling whatever in C programming you might have seen, right? You create a binary, and again, behavioral level to architecture level not possible, right? You don't do behavior to architecture, rather than you go to architecture to behavior level. Okay, and this process is called synthesis. Did you understand? Okay, thank you, Madhubala. Now, moving to again next question. So, if a combinational behavior is described using process statement, okay, so there is one statement which is called as process statement. Which signals must be present in the sensitivity list? Anybody wants to answer this? Okay, Khalil is saying A. What about other students? Madhubala is saying C. What about other? Sanjay Rana is also saying C. Anil is saying A. Anybody else? See, uh, the answer is actually A. All the input signal of the combinational logic, right? So suppose whenever you define a process, how do you write a process? Is suppose you define what you say a NOR gate, okay, or say MUX. How do you write a multiplexer? Okay, multiplexer you define. Okay, so if you want to define the multiplexer, what you do, you know the code, okay, and I will try to. So if 0, so if select equal to 0, right, the output will be d equal to a, else if the select equal to b, d equal to b, or output equal to b, something like this multiplexer we are designing. Okay, what 2-bit multiplexer, a and b, and this is my output, something like that. Okay, this is my output equal to a and output equal to b, and you want to design this, right? So how do you define? You write process, okay, and then you have two inputs, a and b. Okay, so whenever input comes, so process means that whenever input will come or whenever input will change, this statement will be executed, and inside that you will write begin. Okay, and then what you do, you write, say my output is out, okay, output equal to, and how do you write this logic? Let me write it for you. Not, okay, uh, so what it will be, right? If this is select, right, so it will be select bar a plus select into b, right? Everybody agrees with that? Out equal to select bar a plus select b, right? We have discussed this is and, okay, and operation here. This we have discussed in various lectures, that how do you write the equation for multiplexer. So what I will do here, not of select, not of select, okay, and then after and a, okay, so I will put a bracket, not of select, select bar a, or means plus, right, select and b, okay, This is how you write into HDL, and then you will end process. Okay, you will write end process. Earlier, what you have seen? Earlier, we have seen the entity. Entity just a definition of port. Okay. If I want to write an entity over here, okay. So if you see, I will just go to your entity definition. Here it is. Entity of is and port. Here you have to define like this. Okay. So here, right. So if I want to define the entity of this, so first I have to define the entity. Okay. So entity, I will write mux. Okay, mux 2 into 1, 2 plus 1. Okay, so I define the port of here, right? And in the port, what I will do, I will write E, then B, then select. Okay, and then I will define what is my output. Output is out. Okay, and what I will do, I will write the column, and in the column, this is my input standard logic. Okay, again input standard logic. This is also input standard logic, right? This is my output standard logic. Okay, so combining these two code in the VHDL will make your entire what you say multiplexer. You have designed the multiplexer using that. Okay, so if you want to design any kind of logic, you write the entity, you write the process, and you will get your design, right? Now you have to just, I will just repeat what I have said in the last question where we have discussed about entity and where we have discussed about process. Is in the entity we define input, what is the direction, all the ports, and what kind of port it is, and standard logic, and the name of the input. In the process, uh, we actually define the hardware. This is my hardware. Okay, and what we do is we write down that, okay, when does my hardware will give my output, whenever input will change, right? So input name will be defined in the process. Is that clear, everybody? Is that clear? Okay, nice, right? So see, we have discussed about designing a very small module also. Okay, so that's good. Moving to next question, which is a very simple one. What do you mean by microprocessor, and what does it contain? Microprocessor, what does it contain? Please note, this is microprocessor, not microcontroller. Okay, so what do you have in the microprocessor? Anybody want to answer? D. Okay, B. B. Okay, I have two options from B. Madhubalan is also saying B. Ranjit is saying A. Okay, what about others? Okay, so let me give you the answer. Yes, Kanil is saying A, Khalil is saying B. Lot of disparity. Okay, so see, if I have a system, in that system I will have a microprocessor. Okay, and this system will have my input and output, I/O. Okay, input and output. This system will have my memory. This is my memory. This is my microprocessor. Okay, so please note, I/O is not a part of microprocessor. Again, memory is also not a part of microprocessor. Microprocessor also only contain the CPU, the control circuit, and the register circuit. Okay, so the answer is actually B. Okay, so microprocessor, and in the micro, so this, the entire block which I have designed is what we call as microcontroller. Okay, so anybody wants to name me one microprocessor and one microcontroller? Anybody? Please type in the chat if you know the name of one microprocessor and one microcontroller, such that I understand. you know. You type the name of the microprocessor and the microcontroller, you know. 8085, what it is, microprocessor or controller? Manjunath is saying microcontroller 8051, and Sanjay Rane is saying, okay. So, okay, 8086 is a microprocessor. Okay. So 8085 is a microprocessor. 8086 is also a microprocessor. Okay, and 8051 is a microcontroller. Right. Whenever we discuss about controller, it will have all the memory, I/O, and the ALU, everything. Okay. While your so microprocessor is the processor itself, right? Not CPU. Is the processor itself. In the processor, you will have ALU, control circuit, and the register circuit. So I hope uh, you got the question. Now moving to the next part. Again, a very simple question. How many pins are in the 8085 microprocessor? We've just discussed about 8085 microprocessor. How many pins are there? Anybody wants to answer? Okay, Sanjay Rane is saying 40, Khalil is saying again 40, Manjunath. Everybody knows. So yeah, 8085 has a 40 pin. Okay, and now in the current scenario, if you see whatever ICs is come is way beyond 100, 200 pins we will have. Okay, so that's the change we have. Why we require so many pins? Because we have so many peripherals, right? You have so many memories, and you want to connect everything. So that is the reason why you require multiple pins. So earlier it was 40 pins in the 8085, but if you come to new processors, you will have in the pins in the order of hundreds. Okay, so that is done. Now the question is, which of the following is not a reason to make the address and the data line multiplex in 8085 microprocessor? Please note that the address line and the data line are multiplexed. Okay, what do you mean by multiplexing? uh, so suppose if you are getting a 16-bit data, okay, using 16 lines. Okay, so what I want, some of the lines can be used for both data and address. Okay, and all the lines can be used for data, but this is the multiplexing. Sometime it will be used for data, sometime it will be used for address, right? So what are the answers we have? Okay, we have E, to save the chip area. B, we have to reduce the code. The question is, which is not the reason? Okay, not a reason, right? Which is not a reason. So what does it will do if you do the multiplexing? What does it will do? And why do you want to do the multiplexing? And here, which is not the reason that is asking. See, I have, I think, okay, we have two answers, D, one answer C. So let us see. See, why the multiplexing is being done? Whenever you are doing multiplexing, you are saving hardware. Okay, because you are using the same resource, and you are trying to make both data and address lines, right? So obviously if you are not making more hardware, it will reduce the chip area. So this will reduce the chip area. So this is the reason. Okay, this is a correct reason to have address and data line multiplexing. Second, it will also reduce cost because you are fabricating lesser number of hardware. So again, this is also correct reason that, okay, this is the reason why you do address and data line multiplexing. It will also reduce the complexity because now you have only data and address line, and 16 lines can be used, right? So if you have more lines, more complex the hardware will be. The only reason which will not come, because see, whenever you're doing multiplexing, see, you are giving time. uh, uh, at one time you'll be sending address, the other time you'll be sending data, so your time will be increased. Okay, so this is not the reason. Okay, so this is the correct answer because the time will increase, not decrease, right? Whenever you want to do multiplexing, the time or the number of cycles will increase. So the answer is D. Any doubts, any questions on this? I hope there is no question. Then Okay, so we had only 11 questions. It was a very short session because we were discussing about microprocessors and the microcontrollers, and we have discussed something about what we call as hardware description language, right? So see, this kind of these are basics, very basic questions. In the next tutorial, what we will try to do, how to prepare for the final exam. Okay, so how to prepare for the final exam? The best suggestion which I have is go through all the question which has been you're doing in the assignments, all the question you should go through. Second, go through all the question which I have discussed and the other TAs are discussing, right? You have all the materials accessible to you. You try to solve all the questions, go through all the lectures. These are the three things. If you do, you will easily pass the exam, right? And if you want more, you can try solving some of the gate question, right? That is just for practice purpose. But I think your assignments, the question which I have been discussing, the other TAs are discussing, and the course material will help you to clear the exam easily. And how to approach the problematic question. See, in throughout the lecture series, right, we have discussed how to approach the question. First, what you have to do, you have to break down the question into multiple parts if it is a very long one. If it is a short one, like what we were discussing today, you can answer it easily because it was more than remembering rather than analyzing the question, right? But if you want to say analyze and the questions are like in the designing, you break down, you go in step by step. Okay, so the approach will differ from the question to question, but all the question which will be coming into exam and all, right, it will be similar to what we have discussed in the assignments and what we were discussing in this kind of uh, the sessions, right? Whatever that been discussed by other TAs also. The best way is to practice lot of questions, and you can also go through some of the books and the gate questions which comes. If you practice that, I think that will be sufficient to crack this. I hope I have answered your question, Kali. Did I answer your question, Kali? Say some website. uh, you can type, right, gate questions for last year question. You can type in the Google, you'll find ample of websites. I cannot provide you the exact websites, but you can, if you type, you will get so many websites. You start answering each of the questions. Okay. Anybody else has any question about the exam, or if you guys are understanding what you're going through the course? And this last part, what we are discussing now, maybe in the, because many of you have not watched, I think, the video of VHDL, and you should go and watch all of these, right? I'll be discussing couple of programs of using hardware description language in the next tutorial, and we will see how to design couple of hardware. Today we have designed multiplexer, but complete full-fledged hardware we will design, and you can expect questions on the basis of writing programs and answering, okay, what this program will do, okay, what kind of behavior the program is showing. So that kind of questions can be asked. Okay, then it was a short session today. Which topic is more important? Every topic is important, Khalil. So yeah, we don't differentiate in the topic. So you go through all the lectures right from the beginning to end, right? Everything will be given an equal priority. And please note that I am not designing the question. So yeah, the professor will design the question, the NPTEL will design the question, and you can uh, you can go through all the questions and or try to solve all the topics equally. Okay. Okay, then if you do not have any further question, then we will leave for today. Okay, thank you everyone for joining. Thank you everyone. Hope meeting you in the next session.